So today I was thinking about how I could do this experiment and ask a little bit some different questions from what my classmates have done before on the previous videos. So I was thinking of different size lemons today. I don't have oranges, we're gonna do it with lemons. And I was also thinking about different size containers and containers from different material. And I would like to know if that makes a difference or not on the results of my experiment. So the basic guiding question is whether or not this lemon will float. And I also have two size lemons so that I can give it a try. So I'm going to start with the basics. I'm going to cut my lemon in 4 parts. I'll start with a little one, smaller one. And then I'm going to kind of dissect this lemon, which is not working out very well. And I'm going to try and put in the different parts of the lemon and see how they float or not in the water. Okay, so I've separated the skin of the lemon from the pith, and then I have the actual fruit or meat of the fruit. And then I have the skin with the pith, I think it was called, and I'm going to give it a try. So my prediction is that my lemon, the whole lemon, will float based on my previous experience, and I hope that my students could also make some predictions based on theirs. I'm going to start with the meat, the actual fruit. And I'm going to try it in 3 different containers. So I have a plastic container that's a little bit higher. And let's see what happens. And as we can see, if the camera can get closer, we can see that the pulp actually went all the way to the bottom. It did not float at all. I'm going to try it on the container that's made out of glass. See what happens. And again, it goes all the way to the bottom. And I'm going to try it in a plastic container that's a little bit more open. See what happens. Yep, all the way to the bottom. So I could predict that the pulp was not going to float because it's full of water and it's probably denser than the density that we have right now with water. If I do this with my 7th graders, they would probably know because they've already taken that lesson about density. Now I'm going to try with the pith. We're going to try it in the plastic container, and it actually went all the way to the bottom as well. Let's try it in the glass container. Yep, it kind of tried to float, and then it went all the way down to the bottom. Now I'm going to do it in the other plastic container. Yes, it floats for a little while, and then it goes all the way to the back. Now, I did notice that when I put it in, it's going vertically, not horizontally. So I could also try it that way. I could try setting it as a little boat. And then we can see it actually floats. If I try it on the glass container, it floats as well, but then it goes down. So maybe there is a difference depending on what type of container I am using. And there we go. This one is floating as well. So in plastic containers, my pith actually floats. Now I'm going to try it with just the skin with the pith. Let's try it here first. And actually, it is floating. It kind of went down a little bit, but it is floating. Let me try it over here. Yep, floating again. It wants to go down a little bit, but it is still floating. Let me try and do the same thing here. Yep, floating. But what if I put it in vertically? Yep, it will flip and still float. And that's probably what's going to happen in all of them. Yep, flips and floats. And here, same thing, turns over, flips and floats. Okay, so now I'm going to do it with 1/4 of a lemon that has the pith, the skin, and the pulp. My prediction, it's going to do the same thing. It's going to flip. Let's try it. Actually, oh, no, it did not float on the plastic container. It went all the way down. It did flip, but it went all the way down. Oh, that's different. Let's try it here. Yep, not floating at all, not even flipping, nothing. It went all the way down. And let's see over here. It flipped, but still it did not float. So there's a difference from the other experiments that the class has done. Now this is the fourth. Let's try it with half a lemon. Maybe that will make the difference. It flips, tries to float, but no, goes all the way to the bottom. Let's try it over here. Yep. It's flipping, it's trying to float, but no, it's staying at the bottom. And this, actually, in this container, which is the glass container, it did not flip at all. It's face up. And let's try it in this one. Yep, all the way to the bottom, it flipped, and it sunk. Okay, so let's see if the size matters. On this lemon, I'm actually going to put it complete lemon. So based on this information, maybe size does matter. I'm thinking about that because my prediction was that it would float. And from what I've seen from the other experiments from my classmates, it actually did float, even if it was, half of a lemon or half of an orange. But in this case, for some reason, it didn't happen. So I'm going to put in the lemon that's whole. And let's see what happens. Let's try with a plastic container. And yes, it does float. Let's try it in the, yep, floats. And then let's try it in the other plastic container. And yes, it does float. So based on this information, I can actually make some assumptions. I can make some, gather some data and realize that there must be something with a cut fruit that it makes it sink. So maybe in this size lemon, there's more pulp than skin. And maybe that's why it's sinking. Let me try with this. Let's see if this works. We'll try it on this one first. There we go. This one is floating. So there must be a difference. Let me see here. Same thing. It doesn't even flip. It just stays that way and floats. So there must be a difference between the size of the lemons. And that might affect the outcome of my experiment. Thank you.